want me to start? No. Alex says no. Go back. Okay, is your 12 the back bottom left corner that says answer 21? Okay, so let me give you the numbers that I got so you can see where you stop. So first page, I got 1, 19, 4, 15, 6, and then column 2, 17, 13, 2, 9, 3. I thought you were reading one right here. I got that. What? Oh, no, I'm sorry, columns. Column-wise. I just love y'all. Front, and then I'll do the back. Sometimes it helps if you know the direction to go with your answer. A lot of times with a circuit, I'll look and go, okay, this has got to be the answer because it's the only one that involves kind of what I'm looking for. Now, how do I get there? 11, 8, 20, 14, 7. There we go. Caroline, if we start bothering you, you can always run down to the teacher break room. It's quiet down there. Give me one to start with. 9. F of x. You can do these. You should be able to do almost any chain rule, I would think. 7. Cosine x. So I see a product here. So I'm going to think product property, right? So I'm going to do derivative of the first. What's the derivative of that? Use parentheses. That's exactly right. And use the exponent. So 1/3 x squared plus 7 is a negative 2/3. Is that it? No, because I have to chain it times 2x. All that's derivative of the first times the second plus the first times derivative of the second. What's derivative of cosine? Negative sine. So all of this is derivative of the first. So I changed this to x squared plus 7 to the 1/3. Then I did power, and then I did chain. Mm-hmm. Oh, good. He's only 30 minutes late. So now just to clean it up a bit, because I have to get my answer. Where's 10? Oh, gross. Okay, let's start working with it and see what happens. I'm gonna put everything up top that goes up top and everything in the bottom that can go in the bottom because I have a negative exponent, right? So I'm gonna do, and this stays, the 3 obviously stays in the bottom. So I've got 2x cosine x up top. And in the bottom, I have x squared plus 7 to the 2/3 plus, and all of this is going to be in the top, right? If I'm thinking fractions. Oh, I forgot it. Okay, sorry. Right, in the bottom. X squared plus, actually, I am going to do minus sine x times cube root of x squared plus 7 over 1. Great. Now I need a common denominator, right? So since this is 1, it makes my common denominator fairly easy. I'm just going to do 3 times x squared plus 7 to the 2/3. And I have to do it here as well. Now remember what 2/3 is, right? I'm going to actually change this to 1/3 so you can actually see it happen, because this is where the magic starts happening. All right, so up top, I have 2x cosine x minus sine x times, I've got the same, oh, I forgot that 3 again. I've got the same base with these exponents. So I'm going to add the exponents together. Well, what is 1/3 plus 2/3? 1, right? So it's just times x squared plus 7. That 3 I keep trying to leave out. Well, I had to make the denominators the same. Remember that 3 you said, oh, that's just 1/3. It's just 3 in the bottom. So I had to make the second fraction have the same bottom. So now my bottom is, it was such fun. Yay. Contain yourselves, guys. Calm down a little bit. Okay, do I look like anything yet? Not quite yet. I'm getting dangerously close to looking like 2/3 x cosine. Let's see. Okay, let's do this. Because I see this 2/3 in front here, right? Here's what I'm going to do. I'm going to go, here's one chunk, right? I'm going to take the 3 out of that one, but I'm going to give this one a 2/3. I'm going to move that 3 back up essentially just for that one piece, because it'll cancel out with. Does that make sense to you guys? So what I really did was I said, okay, 2x cosine x over 3 x squared plus 7. I'm looking at it as a separate piece. It's really this, I could write this as 2/3 x cosine x over x squared plus 7 to the 2/3. I would never do that. The only reason I am doing that is I noticed that I looked at my answers on my circuit, and I know that it's probably going to be that one, so I'm seeing if I can manipulate to get it to look like that, which is a good technique for multiple choice questions. Can I get it to look this way if I keep working with it? So that's why I did that. This one had a 3. So now I'm to the point of having 2/3 x cosine x minus, I'm going to move this around front, x squared plus 7. And I'm going to change this just because that's the way they have it in that answer. I'm almost there. I think if I were, and maybe it'd be easier to see had I left it like this, if I kind of distribute this through, right, sine x times each of those pieces in that binomial, I'll end up with 2/3 x cosine x minus x squared sine x minus 7 sine x. All over. Now it looks like number 10. Does that make sense? Like if it's an FRQ kind of thing, I would have stopped here whenever I combine them into one fraction. And even that's not always necessary to combine them. It just depends on what the question is asking you. You can grab the other one there. See, is that the calculator part? Yeah, okay. That makes sense? You finished that fast. What else on your circuit? Are y'all okay? Are y'all down and sad? What's wrong? Don't be, Greer, you do not look happy. You don't know what's going on? You don't know what to ask because you're not sure what's going on. Is that what's wrong? Is it the algebraic manipulation? Is it the fractions? So because the first part is just taking the derivative, right? And that's okay for you. It's the manipulation. That's hard. That's hard to get it to look like something else, if that makes sense. And the only time you're gonna have to do that is in a multiple choice situation where they give you these, you know what I'm saying, and you have to see, can you get it like that? We'll practice some more with it for sure. What else on your circuit? Yes. Number 12. It's actually not as easy. Oh, well, maybe that's not. G of x equals 3x squared minus 6x. H of x equals the square root of x. And we're going to talk about composite functions a little more today. F of x equals h of g of x. Then what is f prime of 1? Well, the derivative of f, this is just chain rule, right? Outside in. So I do the derivative of the outside, but leave the inside alone, and then multiply by the derivative of the inside. So I'm going to do that, but this time I'm going to change everything, all my x's, to a negative 1. Yep. Either way, what I did whenever I worked it, I write this, and then I come to the side and I say, okay, come up here and go g prime of x equals this, h prime of x equals this, h prime of 1 equals this, prime of, and I do them all off to the side, and then I plug in. Whichever's easier for you, though. You could. You could. You're going to end up doing the same thing. You'll end up doing chain rule, and you'll do derivative of outside it. But if it helps you to see that better, I think that might be what Alex was saying. Then that's fine. That's because that's the way you're used to doing it in Algebra 2, right? I just see it better this way with chain rule. I think it's a little easier. But if you would rather plug the functions into each other and then take the derivative, that's absolutely fine. I am going to go ahead and say the derivative of g is 6x minus 6. The derivative of h is 1/2 x to the negative 1/2. I need g of negative 1. G of negative 1 is 3 plus 6, which is 9. I need g prime of negative 1. Negative 6 minus 6 is negative 12. So let me go ahead and plug in what I know now. I know g of negative 1 is negative 12. G prime of negative 1, oh, I did that wrong. G of negative 1 is 9. And g prime of negative 1 is, now I need h prime of 9. 1/2 times, did I say 9? 9 to the negative 1/2. This is confusing, y'all. No. 9 to the negative 1/2 is 1 over the square root of 9, so it's 1/3. Sure. If you went the other way with it, so if I did h of g of x. So h of g of x is 3x squared minus 6x. So h is the square root of x, so this is the square root of 3x squared minus 6x, right? And then you found the derivative. We'll do power rule first, so 1/2 times 3x squared minus 6x. Negative 1/2, and then chain it. And now I'll find f prime of negative 1. 1/2 times 3, negative 1 squared, 6, negative 1. Negative 1/2, 6, negative 1 minus 6. This looks very similar. This is 1/3, so I got 1/2 times 1/3 times negative 12. Which should come right back. So whichever way is easier for you. It doesn't matter. The only problem is when you get to ones like if you look at number 20, where you have to be able to do it like that. You know what I'm saying? You have to understand what that is. But there's no algebraic manipulation in that either. It's just a table of values. No, that's okay. That's all right. What else? 18. For what values does y have a horizontal tangent? I had a lot of fun working this one. These problems. I can't believe y'all didn't like them. I'm sorry. It totally distracted me on Thursday. Getting my stuff done. All right, so I need derivative first, right? Because anytime I'm talking about a tangent, I need a slope. So I think that I will do, what did I do? I did quotient. It may be easier to bring that t up and do product. Whatever, it doesn't matter. We'll do quotient. Is that what y'all did, was quotient? Or y'all didn't make it this far? Okay, I did quotient. Derivative of the top, which is 1/2 times 3t minus 2 to the negative 1/2. Chain it times the bottom minus the top times derivative of the bottom, which is just 1, all over bottom squared. Now remember it said, where does it have a horizontal tangent? Horizontal tangents happen where? 0, right? When the slope is 0. So when does a fraction have a value of 0? When the top equals 0, right? So I'm going to work with this just a little bit so I can really figure out the top here. I think that's what I did. Yeah. I feel like whenever I did this, I did top, and then I did top again. Like, I feel like I did, okay, when is the top? Equal to 0. Then I cleaned that up a little bit and said, well, this is 3 over 2 times the square root of 3t minus 2. 3t minus the square root of 3t minus 2. All I did was took the top and set it to 0, right? Because that's what I want to know. When does that happen? Now I got to do the top again, right? But I got two different fractions, so I got to find a common denominator. Luckily, one of the denominators is 1. What's wrong, Hope? Yes. So this piece moved down to the bottom, and since this was a 1/2, the 2 moved to the bottom with it, right? And then the 3t stayed up top. So I'm going to give this second fraction this denominator. Now everybody's got the same denominator, right? And this is actually just going to become, the square roots are going to cancel, so it's going to be 2 times 3t minus 2. So I end up with, I want to know when does, I'll write it out for you. I'm back to the scenario of I just want to know about the top. That's exactly right. Even though this is all technically in the top, I'm back to still, I just need the top. So now the bottoms are the same. I'll distribute a -2 through here, so 6t plus 4. Oh my gosh, please be what I got the first time. No, it's supposed to be 4/5. Oh, what? Yeah, this -2. Makes sense. And of course, t is. Mm-hmm. Uh-huh. This one. She did, and then she cross multiplied and solved for t. You can do that. That's fine. Sure. Yeah. If that makes more sense to you. Yeah. So what she did was she knew to set it equal to 0, but then what she did was she took this over here. So she had it equaling each other. And then because this was a fraction, so if you have 3t over 2 root 3t minus 2 equals square root of 3t minus 2 over 1. Yeah, the radicals cancel. Which worked here because you had those radicals were the same and they canceled, but if it didn't, then you'd be in another conundrum. But yes, absolutely. If that works and you understand it, do it that way. Yeah, sometimes y'all just like soak it in as you stare at the. Look at the pretty Christmas colors. Which one? 14? Bless you. I'm looking for 14. G of X. This one looks so easy, but it wasn't. Looks can be deceiving sometimes. 1 over the square root of the tangent of 3x squared. The very first thing I did was change that from a fraction because I hate quotient rule. So I made it tan of 3x squared to the negative 1. And then I started chaining. I did power rule and just started chaining to do this. So negative 1/2 times the tangent of 3x squared. The 3x is 3x squared. To the negative 3/2. Now derivative inside, what's the derivative of tangent? Secant squared. Now the derivative of inside. And now I just have to get it to look like something, one of the answer choices. So I know I'm probably going to need just one fraction here. I see a negative exponent. So I'm going to put everything up top that stays up top, everything in the bottom that stays in the bottom, and see what happens from there. I've got a negative 1 up top. I'm going to draw my fraction bar. This obviously moves down to the bottom with the 2 here because it's a half. So 2 tangent 3x squared. Now this is to the 3/2. This is up top and this is up top. 6x secant squared. Does that look like anything yet? No. 6 and the 2 can simplify. Change the form there. So that would be square root of tan 3x squared. Y'all. Yep. Oh yeah, that was unit circle. Yeah. Okay. What'd you get for your theta value and your sine? You got the d prime of pi over 4 is negative 3 sine of what? Okay, we'll do it. You good, Hope? Okay. All right, 15. G of theta equals cosine 3 theta plus pi. And I have to find G prime of pi over 4. I'll find G prime first. I wish I could make this a little more exciting. I don't really know what to do though. Sparking problems. Greer looks miserable. I'm so sorry. Alright, I'm going to do the derivative of cosine, which is negative sine 3 theta plus pi. And now I'm going to chain it. Derivative of 3 theta plus pi is just 3. Theta is just your variable there, just like an x. So I really have negative 3 sine 3 theta plus pi, and I want the derivative at pi over 4. So negative 3 times the sine of 3. I'm going to plug pi over 4 in for theta. Negative 3 sine 3 pi over 4 plus pi, which is 7 pi over 4. Pi is 4 pi over 4. Or 4 pi over, yeah. So 7 pi. Which is in fact on your unit circle. So if you take out your unit circle and you go to 7 pi over 4, which is where right here. what is the sine value at 7 pi over 4? Negative square root of 2 over 2. Again, the over 4s there are always going to be root 2 over 2. You just have to decide, is it positive or negative. So determine what quadrant you're in and go from there. This would be then a negative times a negative, which is a positive, so I get 3 root 2 over those. Anything else? You fixing to fall asleep, Henry? Been trying to sleep with my windows open. My stupid ducks keep going. Do you want some ducks, Abby? Don't you have like a little? Oh my. We poured a hole. We're doing a patio, and we poured all this kind. Like we just paid this guy a crap. We haven't even paid him yet. We're fixing to pay him a crap ton of money. And he literally finished on Thursday. And Russell walked out there yesterday, and there is duck poop all over the new patio, and he is livid. And he's like, "The ducks are going. They're done. I'm done with ducks." They're really nasty. My husband wants to in the next couple sections, but this is just kind of to start introducing it. What? Yes. This essentially just is a derivative of a composition of functions. That's all this is. And it's where y'all said, can I just plug one into the other kind of thing? It's just another way to do derivatives of compositions of functions. So for instance, number 33, it's easier just to show you with an example, says, let f of u be u to the fifth. This is why we call it u substitution. We let u represent some function. Okay. Are you okay, Caroline? Are we bothering you? Are you sure? And then let u be g of x, which is the square root of x, and then it says that x equals 1 because it asked us to find f. They use this notation at 1, or at the value of x, whatever the x is given. And they give you this x. So really all I'm doing is I'm finding this derivative, essentially, right? So I'm finding f of t of x. Okay. But to do that, they just said, okay, well, here, let's, instead of writing g, let's just put a u in there to hold the place so that it's a little bit easier. Because if you think about what I do whenever I do this, remember it's the outside times, or leave the inside alone, times the derivative of the inside, right? Do we all agree with that? Is that okay? So this, if I have a u in there, really all I'm doing is the derivative of f is going to be the derivative of all this, but then I'm going to have to do the derivative of u after. Remember how we follow everything with dx, but dx is always just 1? No, okay, it's okay. I'm going to just do it, and then you'll see that it's... Yeah, I'm going to say I'm going to just erase all this. I'm going to stop. Oh, here we go. Yep, just do it. Okay, so f of g of x at 1. So what I'm going to do, I'm going to first find the derivative of f, which would be what? 5u to the 4th, right? But anytime we take the derivative, we also have to chain it. So because this is representing an entire function, then I need to do times the derivative of that u. Whatever that u is, find the derivative of that. Does that make sense? Are y'all following me? So yes, du is going to be the derivative of g. So 1/2 x to the, that's exactly right. If you're a plug-in kind of person, this is the same thing as this. I'm just chaining it is what I'm doing right now. Again, this is setting you up for u substitution. It's going to be really helpful when we have some kind of wonky things that we have to find derivatives of. So now what I can do is just plug in what I know. Well, u is the square root of x. So I've got 5 times the square root of x to the 4th. And then I know du and it actually asked me to find it when x equals 1. So I might even go ahead and plug that in now. So I don't have as much algebraic manipulation to do. Yeah. Well, 1 to... And I know this looks so overly complicated for what I really found, right? It's 1 over the square root of 1. So I'm not going to force you to do it this way, but this is the way it's laid out in here. It's a good thing to start getting familiar with it, but if you're just going, what in the world ever, I'd rather just do this and plug it in, that's okay too. So if you wanted to do f of x is equal to the square root of x to the 5th plus 1, and then do the derivative, you get the same thing. You do. But this is not, this is just the chain, is what that's doing. But yeah, you do. It is. So we're taking kind of we're making it more complicated than it is, so that when you get to a harder problem, it makes sense why you're doing it. Let's do another one. Go 33. Yeah. Let's do 36. Same deal. Because my u is the same all the way through here, I'm only going to need to multiply the entire thing by 1 du instead of each time I do it change. Makes it a little bit easier. I'll show you what I'm talking about. Remember what I'm trying to find. I'm finding this. That's just another way to write f of g of x. What shall we do? 1 plus what's derivative of u is 1. What I'm gonna do is I'm gonna come at the end and I'm gonna do times du to chain it. Yeah. Okay, here's what I'm really doing. This might make more sense to you. I'm doing the derivative of f with respect to u, okay? Which means the derivative of u is just 1, right? But then what I have to do is I have to come back and do the derivative of u with respect to x. So that what I end up with in the end is the derivative of f with respect to x. Does that make more sense? Yeah. Yes. Yes. So this would be -2 cosine -3u. But then I got to chain it, right? Sine. Because this is cosine -2. Because it's in the bottom, right? So if it's ever in the bottom, I can move to the top. I don't want to do quotient rule there. Yeah, and then I did the power rule. Yeah. Okay, so think about it like this. If it was f of x equals x plus 1 over cosine squared x, how would you find the derivative? You would have all of this, right? Because it was power rule first. Remember when I have trig functions, I do power, trig, and then what's with the trig. Yeah. Yes, this is going to be negative here, sorry. So then it would be positive 2. Sorry. Y'all, do you see what we're doing here though? I'm taking the derivative of f, but I'm not worrying about x's, right? So I'm doing the derivative of f with respect to u. Okay, so that means, what that means is if I have y equals when these are x variables in here, then y prime is the same thing as dy dx. That means I take the derivative of y with respect to x. That means my variable is x, that I'm, right? If this is x squared, then this would be 2 times x. Here I'm taking it with, and we always said we do this dx, but it's always 1, right? Because the derivative of x is 1. So it's irrelevant. But here, I'm doing the derivative of f with respect to u. But because u is a whole function, I have to also chain it. So I have to do the derivative of u with respect to x. And what it gives me in the end is the f dx, derivative of f with respect to x, even though f wasn't written with an x in it at all. And we're going to do this when we do implicit differentiation in a few days. Okay, so let's finish working with this just a little bit. I have 1, and y'all are right, that's 2, positive 2, cosine -3 u sine. But I need to multiply by du. Okay? So now let's go in and let's think. What do I have? What do I know? I know what u is. U is pi x. Pi x. Pi x. And what is du? Pi. The derivative of u with respect to x is just pi. So now I have, I'll just write this a little bit prettier before I plug in my values. Now it tells me to evaluate when x is what? Oh, great, wiggling. Okay, Alex is going to be excited because this is going to be my unit circle. 1 plus 2. I got pi over 4, that's exactly right. Pi over 4, which pi over 4 is nice because that's just root 2 over 2. First quadrant, everybody's positive. So what is the cosine of pi over 4? Root 2 over 2. It is to the negative third power, though. Pi over 4. You look for pi over 4 and then the sine and the cosine of your x and your y value. So you always look for the angle, whatever is inside, look to the sine or the cosine. That's your angle. It'll either be in degrees or radians. And so these are your radian values. Oh, that looks so sad. Are you okay? You have resting sad face. Okay. Y'all's favorite part now. I'm going to mark those out. This one has an exponent on it, so I can't mess with that one. But this is just 2 times. I can multiply in any order I want to, right? So I'm just choosing these 2. I don't know if that's going to help me or not. I'm going to try that. I think what I'll do is take this to both, but make it positive and flip it. Okay? So I end up with pi times 1 plus 2 to the positive third over the square root of 2 to the third times the square root of 2. This is this written 3 times, right? So I'm going to take one of them away. I flipped it since it was negative. Yep. Yes, that works. I don't want to do too much at one time. So yes, that cancels. Well, what is 2 cubed over 2? 2 to the second, which is 4. That's right. Or 8 over 2, which is 4. However you want to do it. I subtracted exponents here, but if you want to multiply it out, that's fine too. So now I have 1 plus 4. So it's just 5. That is ridiculous. I don't know why I want it to be some long, complicated, nasty value because I worked so hard to get there for it just to be. Yeah. Oh,